Hello, and welcome back to Maths with Mr Amison. In this video, I'd like to talk with you about when to use the different versions of trigonometry. I'm assuming a knowledge of the sine rule, cosine rule, area sine rule, normal trigonometry and Pythagoras for the purposes of this video. I'm going to use these 6 questions as examples for you to help us to decide which rule we need to use. Question 1 and question 2 are right angle triangles. Therefore, the rule that we need to use with them is going to be fairly basic. Whenever you have a right angle triangle, we're either going to use normal trigonometry or Pythagoras theory. In question 1, we have an unknown angle and we have two other sides given, apart from the 90 degrees. Therefore, we have the opposite side, an adjacent side, and an unknown angle, so we're going to have to use trigonometry in a case like that. Whenever we've got two sides and an angle that we're interested in, it's trigonometry. Question 2, we're given the hypotenuse, but we can't label these as opposite or adjacent because they're not. The only thing we can do with this is to use Pythagoras theory, because we are interested in 3 sides of a right angled triangle. Question 3, we're asked to find the area. Because we're asked to find the area, we're going to have to use the area sine rule. However, the area sine rule requires us to know side lengths that are adjacent to an angle that is given, or an angle that we're trying to calculate if we're given the area. So in this case, we can't use area sine rule straight away, but we are going to have to use it. So what we need to do is think about what else we can do. In this example, 93 degrees is opposite our 9 centimeters. 5 centimeters is opposite this angle over here, which means that we can use sine rule to figure out the angle at A. And once we've figured out the angle at A, because there's 180 degrees in a triangle, we can calculate the angle at C. The reason for that is so that we can use the area sine rule with the 5 and the 9 both of them being adjacent to the angle here at C. It's side, angle, side. 2 sides and an included angle. Question 4 does not have any pair of opposites that we know. We know one of each of these pairs. And for us to be able to use sine rule, we have to know what both of them are. One pair is fully, and I have to have something opposite my unknown as well that I know. So in this case we can't use the sine rule. We don't have any pair of known opposites. But what we do know is that we're interested in all 3 sides and one angle. When our unknown side is opposite our angle, or when we have an unknown angle and we've got all 3 sides, the best option is to use the cosine rule. So we have b squared equals 9 squared plus 5 squared minus 2 times 9 times 5 cos 87. Question 5, we have a similar setup. We have 3 known sides and 1 unknown angle, which means that we can use the cosine rule. However, that's not the only rule we can use, because we have 11 centimeters opposite to the 100 and the angle over here opposite to the 5 centimeter side. Because of that, because we have a pair of known opposites and these opposites we know one of them, we can therefore use the sine rule to figure out our missing angle up here. Question 6 is not a right angled triangle, nor do we have all the information we need for sine rule. So in this case, we have a pair of knowns here, but from our unknown we don't know its opposite side, and we don't know anything about the other angle or the opposite side over here. So we don't have enough information for sine rule. Also, we're not interested in all three sides around our shape, therefore we can't use cosine rule. We have no information about the two missing side lengths, so we can't use cosine rule. So look out for when each of these rules can be used. Sometimes you'll get a question like question 6 where it's impossible without further information, but it's not likely you'll come across many of those. Usually questions 1 through 5 are the kind of questions that you might get. I hope you found that useful. I'm going to leave you with this question to finish off for you to do. The angle ADB is 120 degrees. The angle DAB is 25 degrees. Final length BD, the angle CBD, and then find the area of the triangle BCD. Thanks for listening. Feel free to subscribe for any future releases. Have a good day.